Hello everyone, welcome to Electronic Solutions. In today's video, I am going to explain LCD and how to interface the LCD with the Arduino UNO board. Here I am going to explain a 16 by 2 LCD display. 16 by 2 meaning is that there are 16 columns and 2 rows in this display. So the columns are numbered from 0 to 15 and the rows are numbered as 0 and 1. Now whenever you want to select a particular position on this display, then in that case you have to select a particular column number and row number in the specific command that I am going to tell you in my next slide. Now to display a single character, a 5 by 7 matrix LEDs are used in this LCD. Now we'll go for the pin details of the LCD. So this LCD basically contains 1 to 16, that means total 16 pins are there. The pin number 1 is a VSS ground pin. Pin number 2 is VDD, that is plus 5 volt. Pin number 3 is for adjusting the contrast. Pin number 4, 5 and 6, these 3 pins are called as an control pins. Now the pin number 4 is called as an RS, that is a register select. Now this liquid crystal display basically contains its own microcontroller and it has a data register and a command register. So this RS is basically used to select the data or the command register. But in this case we are going to connect this RS pin to one of the IO pin of Arduino, and we are not going to send any data on this RS because the Arduino will take care of all these things. The next pin is RW, that is read, write. Now this LCD display is basically used to display the data, and that means we are going to write something on the display, and therefore this pin number 5 or read write pin is always connected to the ground, that means in a write mode. The next pin is a enable pin. So again this enable pin is connected to one of the IO pin of the Arduino. The next 8 pins, that is D0 to D7, are the data pins. That means we are going to send the data through these pins D0 to D7. Now the data can be sent in two different modes. The first mode is a 8-bit mode and the second mode is a 4-bit mode. In case of an 8 bits, we are going to connect all these D0 to D7 pins from LCD to the 8 pins of the Arduino board. So in case of 8-bit mode, we are going to send 8-bit data at the same time. But see how many IO lines of the Arduino get utilized if we use an 8-bit mode. So basically these 8 pins plus 1 pin for enable 9 and 1 pin for register select. So basically 10 pins are used out of 14 pins from Arduino board. I have already explained that the Arduino board has total 14 digital IO pins, and out of which 2 pins are for serial communication. So that means there are total 12 pins available, and if we use a 8-bit mode, then in that case we are using total 10 pins of the Arduino. Then what about the sensors? That means if you are going to connect the more sensors, then the data lines will not be available or it may be insufficient for your Arduino board, and therefore it is always preferred to use the display in a 4-bit mode. So in case of 4-bit mode, instead of 8 pins we are going to use only 4 pins, that is D4, D5, D6 and D7. In this case the data is to be sent in nibbles. That means the higher nibble is sent and then the lower nibble is sent. So the advantage of using 4-bit mode is we can save the 4 IO pins of a Arduino board. Now the pin number 15 and 16, these two pins are for backlight adjustment, and therefore we are going to connect the pin number 15 through one resistor to plus 5 volt and the pin number 16 to ground. So these are the pinouts of LCD. Now we'll see the connection diagram of the LCD display with that of the Arduino UNO board. So the first pin, that is VSS, connected to ground. Second pin is VCC, that is connected to plus 5 volt. Pin number 3 is for adjusting the contrast. So this pin number 3 is connected to the variable terminal of the potentiometer. So we are going to use one potentiometer of say 10K. One terminal of potentiometer is connected to plus 5 volt and the second terminal will be connected to ground, and the variable terminal will be connected to pin number 3 through which we can adjust the contrast. Pin number 4 is a register select. So as I have already explained, it is connected to the pin number 12 of Arduino board. Pin number 5 is read write. So as we are going to use it or in a write mode, it is connected to ground. Pin number 6 is enable. So again connected to Arduino pin number 11. As this is a 4-bit mode, the pin number 7, 8, 9 and 10 are not used, and 11, 12, 13 and 14 are connected to pin number 5, 4, 3 and 2 of Arduino UNO board. Then pin number 15 and 16 are for backlight. So these are the simple connections of LCD with that of the Arduino board. Now we'll have a look at the code of the LCD display to interface with the Arduino board. What are the different commands that we are going to use for LCD? So this is a code. So the first important thing in this case is you have to add a library, that is liquidcrystal.h. Then you have to mention all the pin numbers that you have used with the Arduino. That is, here I am using pin number 12, 11, 5, 4, 3 and 2. If you are using some different port pins, then you have to mention those pins in the bracket. Now in the setup loop, I have written the first function, that is lcd.begin 16, 2. So this command is basically for initializing your 16 by 2 LCD. Then next is a setting the position of your cursor using the command lcd.setCursor 0, 0. So here I am starting my display or my command from 0, 0, that means from the first position. Then I am going to display here the name of my channel, that is electronic solutions. So I am going to print the electronics on the first line and the solution on the next row, that is the second row. So for that purpose I have set this cursor to 7, 1. So now we'll download this code in our Arduino board and we'll check the output. So here you can see the hardware connections. I have connected LCD to the Arduino board, and here you can see one potentiometer is connected to adjust the brightness of the LED. Now I will download the program and I will show you the output on the LCD. Yes, so here you can see the output, that is electronic solutions is printed on the LCD board. Now I will change the potentiometer value and I will adjust the brightness of this LCD. Now see, I will change this potentiometer. Yes, now here you can see the letters will not be displayed on the LCD. Now again, if you adjust the brightness and pot value, you will get the output again. So if you like my video, then please share the video with your friends and don't forget to subscribe the channel. Thank you guys. Thank you so much.